So we've looked at the uniform distribution and the exponential distribution as far as finding the probability that we're above, below, or between certain numbers. And in both of those, we had to do a little bit of math. We had to do some subtraction and division for the uniform, and we had to do the exponential key in the calculator for the exponential. The math with the normal distribution is so ugly we can't even think about doing it. It's a hideous function, and then we actually have to do calculus to that hideous function, so we're not going to. We are going to go straight to the calculator and use a function called normal CDF, which gives us the percentage of the population that falls between two numbers. We'll call them A and B here. So we go to normal CDF, and we have to tell it four things. We have to tell it our low number and our high number, the numbers we want to be between, and then we have to tell it the mean and the standard deviation of the population. And we'll do a few more examples here than we're used to doing with these, because the calculator steps and the variations are worth going into. Here's our distribution for IQs. We'll use these because they're something you're familiar with by now. We got our mean of 100 and our standard deviation of 15, which we have to be given. We can't find those. And we want to know the probability that person chosen at random from the population will have an IQ between 85 and 115. Now that corresponds to one standard deviation above and below, and we remember from the empirical rule that should be 68%. So let's give this a try and see if we do get 68%. We're going from 85 to 115 here. Try and tame that shadow a little bit. This key right here, distra, is what we're after. Second vars is distributions, and normal is right at the top of the list. We don't want PDF. PDF is actually the equation of the curve here that's not helpful to us. It's helpful to some people, but not to us. We want CDF, which stands for cumulative, meaning the area between two things, rather than the height of the curve at one thing. Again, we wanted 85, so 85, comma, 115, comma, the mean is 100, comma, the standard deviation is 15. You can close parentheses if you want. It's not going to hurt if you don't do that, but it's a good habit to get into. And we hit enter, and we get 0.6826. So just a little bit more than 68%. We would round it down, so 68% is the best whole number approximation of that. So we got 68% here. Again, ugly 6. The second part of the empirical rule said that 95% would be between 70 and 130, within two standard deviations of the mean. So let's try that again. Let's go second vars, down one to normal CDF, hit enter to select it, and this time we're after 70, comma, 130, comma, a mean of 100, a standard deviation of 15, close parentheses and enter, and we get 0.954. That rounds down to 0.95, so 95% there, and the second part of the empirical theorem is true. And remember, we talked about virtually all being within 3 standard deviations. I'm going to do a little bit of a variation on this one. Normal CDF again, and I could put in the 55 to the 145, and I would get that, what did we say, 99.7 was the number for virtually all. But instead of that, I'm going to put in -3 and +3, and I'm not going to give it a mean and a standard deviation. If you don't give it a mean and standard deviation, that interprets these as z-scores. So I'm asking 3 standard deviations below the mean to 3 standard deviations above the mean, which should give me the same thing. That gives me 99.7. Okay, so that's going to be the same as if I did 55 to 145, comma, mean of 100, comma, standard deviation of 15, gives me exactly the same number. Okay, so if you know the z-scores for your scores here, you can save the horrible difficulty of typing in the mean and the standard deviation. So I don't expect anybody to use that as a shortcut. But that confirms our empirical rule, the 68, 95, and 99.7. Now, what if we just want to find the probability that we are above or below a particular number. So let's say we want the probability that we're above 110, which would be right about there. So we're looking for something less than half, maybe about 30%, something like that. That might be a little high, I'm not sure. Well, we have to kind of trick it. There is no function for doing that. There's normal CDF, which finds the probability that you would be between two numbers. So what I do for this is I put in my bottom number, my 110, and I can't really put in infinity here, but I can put in a number that's ridiculously large in this context. So I'm going to say 1,000. What's the probability I'm between 100 and 1,000? That's going to be the same as the probability I'm above 100. So, comma, 100. Oops, I messed up. I wanted to know the probability to be above 110. So between 110 and 1,000, with a mean of 100 and a standard deviation of 15, it's going to give me 25%. That's within the range that I predicted. I said somewhere around 30 maybe a little lower. So go with 25%. So if you pick a person at random from the population, there's a 25% chance they'll have an IQ that is above 110. What about the probability that they would fall below 80? Okay, 80 would be right there. We're talking about that. Now that's going to be less than that one was, right? That was 25% of the population. So I'm going to guess that's maybe about 15. And the way we'll do that is second distribution, normal CDF, and we got to put in a ridiculously low number like 0. So from 0 up to 80 in a population with a mean of 100 and a standard deviation of 15. And that gives me about 10%. Okay, I was a little bit off there, 9.1%. So let's just round that off to 9. Okay, and that's how to find percentage within a range, or probability if you select somebody at random that they will be within a particular range of the normal distribution. And next time we'll look at our percentiles again.